In this video, we're going to look at expanding triple brackets. And once you get your head around these, you'll actually be quite glad to see this question. It comes up every year pretty much. And once you understand how to do it, we're just building on our skills of the double brackets. And I've got the calculator here to help you to check your answer at the end, because we make quite a few mistakes with these, especially if there's a minus sign in there. So how do we expand triple brackets? My advice is to choose the second two brackets and expand those, pretending that the first one isn't there. Okay. How would I expand these double brackets? Well, we do x times x, x times 4, 3 times x, and 3 times 4. Just like we usually do with the double ones. So I'm going to assume that that process is okay at this level, and that you're comfortable with collecting this together and getting the 7x and the 12. Okay, and all I've done is put brackets around these. That's the only thing that I've done differently. Because what I'm going to do next is just reintroduce the first bracket. Okay, I haven't done anything with it yet. I'm just going to pop that on the front like this. Once I've expanded my second pair to create x squared plus 7x plus 12, I'm now ready to do the same thing, the same kind of foil idea, expanding the double brackets. But with the triple one, we kind of go like this. X times x squared, x cubed, x times 7x, 7x squared, and x times 12, 12x. So I've multiplied everything in the black brackets by x, and then I go to the second term and do these combinations. Okay, so 2 times x squared, 2x squared, 2 times 7x, 14x, and 2 times 12 is 24. Okay. Final stage is to collect everything together. X cubed, there's only one of those. That nearly always happens with the triple brackets. So x cubed doesn't have anything to join with. I have 7x squareds plus 2x squareds is 9x squareds. I've got 12x plus 14x is 26x. I'm going to introduce an error here. Okay, 12x plus 14x. Let's say I made an error. Okay, a simple error. Let's just say 24x plus 24 at the end. Okay. Now you may be thinking, why has he done that? Like, what's the point of doing a silly error like that? Well, when you're doing your expanding triple brackets and there's a minus sign in there, you're very likely to make a small, tiny error, and we want to be able to catch that in the calculator and non-calculator papers. Okay, so remember, there's a mistake in here right now. How are we going to check our answer? Well, just like with everything we've been doing in our earlier videos, so have a little look at those if you're not too sure. We're going to substitute a random value for x into the question and our answer and see if they match. So our calculator has the calc button, and I'm going to choose a small easy value like 2, and the calculator will substitute 2 into here. So it's going to change this to 2 plus 2, 2 plus 3, and 2 plus 4. So 4, 5, and 6. 4 times 5 times 6 is 120. Okay, that's what the calculator's done for us. We don't have to worry about that in the calculator papers. We just have to know that the calculator can check this for us. Let's do the same thing for our answer, which, just to recap, there is a mistake in there. 24x plus 24. We're looking for 120, remember, from the question. We get 116. Okay, so we now know that there's a mistake in our answer. Let's go back a couple of lines and just see if that was correct. X plus 2, x squared plus 7x plus 12. Okay, if this is 120, that means we're correct up until this point because it's still the same as what the question says. We haven't gone off track. 120. Okay, so we now know that this line is correct up till here. Let's do the next line. X cubed plus 7x squared plus 12x. This will be much quicker in the exam because I'm having to use the mouse. When you're using your hands to do this, this is a lot quicker. Calc, still 120. Okay, so I know that my mistake was this final line. The x cubed and the 24 haven't had anything done to them because there's nothing for them to join with, the first and the last terms. So we can check 7x squared and 2x squared. 7x squared plus 2x squared, calc, is 36. 9x squared is 36, so I know that one is correct. 12x plus 14x is 52. 24x is 48. So I know that this one is incorrect. Okay, 12x plus 14x. If this was a minus sign, we could just do this on the calculator. 26. I need to change that to a 26. Now I can go back all the way back here and change this to a 26 now and see if this is right. Yes. Okay, so I know that was quite long-winded in how I modeled to you how we check this in the exam with the calculator, but this is going to help you to identify. First of all, you do it with your answer, and if that's correct, you know you've got those 3 marks and you can just move on. You've literally boxed off and self-assessed yourself. I know that that is correct. Okay, if it doesn't match, we can go back a line or maybe a couple of lines, check that line and work our way through, and we can even check the individual parts to see if we were right. Okay, how do we check this in the non-calculator paper? I would advise you to use x equals 1. Okay, use x equals 1 in your same process. I chose 2 because the calculator, it doesn't matter, the calculator can cope with this. But in the exam, without it, I would like to make this calculation a lot easier. So my first bracket would become x equals 1, so 1 plus 2, 1 plus 3, and 1 plus 4. So 3 times 4 times 5. 3 times 4 is 12, times 5 is 60. So I know that the correct answer should be 60 when I do the same process for my answer. Okay, let's just make that a bit clearer. This last one was 26x, sorry, 26x. So when I do x equals 1, the reason I say to choose that is because we can just do 1 cubed, which is 1, 9 lots of 1 squared, which is just 1, plus 26 times 1, plus 24. Choosing 1 is a lot easier than 2 or 3 because the cubes and everything start to add up some quite big numbers. So 1 cubed plus 9 plus 26 plus 24. If we've done our expansion completely correctly, that should add up to 60. 1 plus 9 is 10, plus 26 is 36, plus 24, yes, that's 60. So I know that these are correct, and I did it the most efficient way possible using x equals 1.